everybody. So yes, I'm Lorena, and I'm going to be presenting work that was done by Randy Swanberg and others in different places on the OpenPOWER platform. So I have some notices there that those of you who download the charts can look at. So first, I assume most of you are familiar with Spark, but if you're not, at a very high level is a big data and analytics platform. It's open source, of course. So it combines, you can have SQL, streaming, machine learning, and graph all in the same infrastructure. And you can work with all the different with a bunch of different languages: Java, Python, SQL, R. And the really cool thing about it, it's in memory, so that makes it perform really well. So we have a graph here comparing it to Hadoop. So runtime, higher is worse, so 110 seconds for Hadoop, and the line for Spark is almost invisible. So that shows how much better it performs compared to Hadoop. So that's about Spark. So I'm about to show you some results on the OpenPOWER platform, and this just outlines what the experiments were. We used the Spark bench, these are the 3 different families of workloads that we use. So machine learning, SQL, and graph, a few different workloads on each of those areas. And the hardware we used was 7-node clusters of Intel Haswell 2620 and our scale-out Power 8 system with 10 cores. So here are the results. That chart speaks for itself, but so on average we're 1.7 times the Intel performance, and you can see on each. So we can say between like 1.3x and 2.5x what the Intel cluster did. And this is without using any of the additional OpenPOWER innovation. So on the next chart, we have a price performance. And again, this sort of speaks for itself. But so you can look at it from 2 angles. You can spend 33% less on infrastructure and get the same performance, or you can spend the same and get 50% more performance, more throughput out of your cluster. So why do we do so well? Here's some of the reasons. Our stream and SQL benefit, of course, from our high thread density and concurrency. So we have SMT8 on 10 or up to 12 cores on our scale-out systems and scale-up systems as well. Really powerful threads, so we can process lots of parallelism, process multiple things at a time, and different stages at a time. And then, of course, we have large caches, memory, and lots of memory bandwidth available. It's close to 200 gigabytes per second on this particular system, which, of course, it's huge for machine learning. And then that means that your core is spending more time doing work than waiting for data to come from the memory subsystem. And then the graph workload also benefits from both of those, the large caches, the memory bandwidth, and the potent thread and core we have. And of course, we have flexibility to go from SMT single thread, SMT2, SMT4, SMT8. That's that. Okay, so if you like what you saw, you're going to be really excited about the next couple of slides. So this is what happens when we start playing with some of the OpenPOWER innovation with this workload. So I'll start with your left here. So 4 times the memory reduction at equal performance. So this means here the y-axis higher is worse. This is runtime, so lower is better. So we're showing that when we add Capi Flash, like about 2 gigabytes of memory, you get the same performance that you get with disk on like 8 gigabytes. So that's where the 4x comes from. And so that means a lot of money savings if you care about that, because Flash is a lot cheaper than memory. And then the other exciting thing is enabling RDMA for this workload. And here are just 3 sample queries that we have. Show 30% better performance, but at the same time, lower utilization, lower memory footprint. These are all great things. And this doesn't even use the CAPI technology. This is just on the Mellanox technology now. So there's work being done to add in CAPI and to make this even more exciting. Okay, this one also sort of speaks for itself. So once we add GPUs to this, this is, by the way, an example of this is an adverse drug reaction prediction built on Spark. And it's pretty clear there. So now we're looking at throughput, so higher is better. And we see the example in the red box. We're doing many, many times better with once we enable GPU acceleration. And overall, it's like 4 times better for the total. Yeah, so 25x speed up on that one stage of the learn billing model. And again, this is using very basic technology. It doesn't include the NVLink, which was put into our next generation platform. So you can expect this to get much better in the future, in the near future. So to summarize, Spark is very powerful, disruptive technology, open source. So we expect to see lots of growth in the near future. And we've shown that it does really well on the OpenPOWER platform. And there's even more innovation coming in using the new technologies, such as CAPI and NVLink with GPUs.